The second term of an arithmetic progression is 7 and the seventh term is 52. I need to determine the common difference, and this is worth 2 marks. So what I'm first going to do is just write down everything that I know. So for an arithmetic series, I know that the general form is Tn is equal to a plus n minus 1d. So for my second term, that's simply a plus d, and I know my second term is 7, that's been given there in the question, and I'm going to set that as equation 1. Now for my seventh term, that's a plus 6d. Again, the 6d comes from n minus 1, so 7 minus 1 gives d. That gives me 6d. So again, my seventh term is a plus 6d, and we know that's equal to 52, and I'm going to set that as equation number 2. Then I'm going to solve simultaneously. Now this one is really straightforward. I can just do the elimination method, so I'm just going to do equation 2, take away equation 1. So I'm just going to rearrange it and write it like this, just so you can see it a little bit clearer, and I'm going to subtract the 2 equations, and there you've got your a's cancel. Then 6d take away d leaves me with 5d, and 52 take away 7 is 45. Therefore, d is equal to 9. Okay, for part B, I need to find the value of the first term that is greater than 1,000, and this is worth 2 marks. So I just want to know when I first hit value greater than 1,000. So I know that my common difference is 9. This was just found in part A. And I know my second term, which is represented as a plus d, that's equal to 7. I'm going to substitute d equals 9, and that leaves me with a is minus 2. So I'm just trying to gather as much information as possible, so then I can then plug it into my general form and determine which value is greater than 1,000. So what I want is that for my general form there, so my Tn, to be greater than 1,000. I'm now going to put in all the data that I know. So I know that a is minus 2, and I know d is 9. So plugging that all in, I get minus 2 plus n minus 1d is greater than 1,000. So in this case, I'm solving for n. I'm trying to find when that happens. So this is now just basic algebra. I'm just going to expand and simplify, and that leaves me with 9. N minus 9 is greater than 1,002. So you can see I brought that minus 2 over to the other side, leaving me with, and then I'm going to bring that 9 over to the other side, and I've got 9n is greater than 1011. Divide both sides by 9. N is greater than 1011 over 9. And it gives me something like 112.333 because I want it to be greater than, so I'm just going to round it up to the nearest whole, so that leaves me with n is 113. And let's just test that. So I'm going to sub in from 113th term, and that leaves me with 1,000. Alright, for part C, I want to find the sum of the first 10 terms, and this is worth 1 mark. I'm going to use this formula here for my sum of an arithmetic series. The reason why I'm choosing this one is it's just simpler and it's very easy to determine my last term. In this case, it's going to be my 10th term. So again, knowing that a is minus 2 and d is 9, I'm going to compute that into my general form. So I know my 10th term is a plus nd. Put all that data in, and I get my 10th term is 79. This here is now going to represent my L. And I obviously know a is minus 2. Plug that into your formula. I now have 10 over 2, open bracket, minus 2 plus 79, and that leaves me with 385. Continue watching other videos on exam style questions relating to arithmetic series and geometric series. In other videos, we also look at investment and loan repayments.